tonight, today, is 4 technologies that will change the world. And I think the best context for this is to take a look at what the last century has had. As many of you know, our company actually turned 100 last year. And I'm almost that old myself. But actually, what was really interesting is I was asked to go out, like many others, and speak about what the company had accomplished and what the industry had accomplished in that period. And it was so fascinating. This is a chart that a lot of us like to use, where we think about what we did is we took computers, both ours, IBM computers, and others in the industry, and we looked back 100 years, because that's really the threshold of computing. By the way, do you know what IBM started making? Our first products were for grinders for making sausage, and then we started making them smarter. That's our first smarter planet. But we go back to 100 years where there was mechanical computing, like meat slicers and grinders, and we started adding calculations, electromechanical, where we were turning the crank. Our first electromechanical computer, the Mark I, weighed 20 tons, and it had a big motor driving it. It was so loud you had to wear earplugs. But if you keep going up through vacuum tubes, discrete transistors, and about where I joined the company in integrated circuits, if you look how much computing $1,000 or 1,000 euros in current currency would buy you, this is a logarithmic scale. Look at that extension. Look. So this is not only growing, it's speeding up. So when you kind of look at that, even though we may have technological challenges as we go, you wouldn't want to bet against this curve. I mean, to put this growth in perspective, if I think about where I started in the company in the 70s and 80s, and took that out here, and the amount of miniaturization in both speed and cost, I took a calculation this morning. If you took a Rolls Royce, you have those here, right? Everyone has one? Yeah? Okay. A Rolls Royce that cost about 25,000 euros in the late 70s, if it had advanced as fast as microelectronics, would cost 18 cents now. And instead of going 160 kilometers an hour, it would go 25,000 kilometers an hour. What I'm going to talk about right now is 4 coming disruptive technologies that I'm very, very excited about. The first would be actually I was sitting here thinking about this, nervous about getting up and talking, and all of a sudden I had this kind of insight that the things I'm going to describe have mapped my career too. So starting here at the very bottom, how do we actually make electronics? We're now at the level where we're using transistors, about 1 billion or 2 or 3 billion transistors in one of our mainframes. You know, in the coming couple of years, we're going to increase that by a factor of 1,000 to trillions of devices inside a single object. Trillions of devices. So once we have that technological area, and this is where I started in the company, we're integrating those into systems, like the mainframe systems of today and the future. We're going from workload optimized systems up to exascale computing. That's 10 to the 15th, 10 to the 18th operations per second. 10 to the 18th. 1 with 18 zeros. And we're going to, that's going to a 1,000-fold increase. Once we actually have done both of those, we're getting huge, huge purchase on bigger things of data. And we'll talk about that anywhere from 1,000 to 1,000,000 times as we go from what we now think of as big data to really big data, really fast data. And eventually, I'm now just moving organizationally from this to this about 2 months ago. Eventually, we're getting into the realm where computers actually can think. And while I haven't moved to that far, I think I'm starting to lose my mind enough that it'll be just in time for me to have a computer that will think for me.